Okay, so then yesterday we finished up with the identities that were in 5.4, which were your multiple angle identities. So what today's one? So Monday we had looked at the double angle identities and we proved the double angle identities. And how did we? What other identities did we use to prove the double angles? They were involved in these two. But what identities did we use to get sine 2u? The sum identities, right? But instead of having a u plus a v, we looked at u plus u, which gave us the 2u. So we used our sum and difference identities to get the double angle identities. Okay? Yeah, I know. We then went from there to the power reducing identities. So sine squared u is 1 minus cosine 2u. Cosine squared u is 1 plus cosine 2u over 2. And then tangent, since tangent is what over what? Sine over cosine, then we can reduce that down to 1 minus cosine 2u over 1 plus cosine 2u. We proved these as well by using the double angle identities. Okay, to figure out, we replaced the cosine 2u with its identity for sine up here and for cosine down here, and we were able to prove that those were identities as well. So those are our power reducing identities, and then we used our power reducing identities then to get our half angle identities. Okay, and the half angle identities, these ones are the ones that are kind of the pain because we've got to determine if it's going to be the plus or the minus. We had to determine if it was the plus or the minus. Now I believe we were looking at then the tangent of 195. Was that correct? Tangent of 195. But I think I pulled out a bad example from there because they wanted us to use a half angle identity, but 195 was not half of a special angle. What was 195 times 2? It was 390, right? Yes, absolutely we can use it. We can. We can, yes. Okay, let's pick back up with that one then. Was it a homework one? All right, doesn't matter. Tangents of 195 degrees. Well, the tangent of 195 degrees is really the tangent of 1/2 of 390. Now, we never deal with angles that are outside of 360 degrees, though. What are we going to do to 390? We're going to subtract off 360. 390 degrees behaves the same way as 30 degrees. 30 degrees. Okay. So this is the tangent of 1/2 of 30 degrees. And now we can use our half angle identity for tangent. Okay. Tangent of 1/2 of an angle says that it's equal to what? What's our half angle identity for tangent? And now again here, folks, let's use to our advantage. We've got a tangent one where we're going to have to determine if it's going to be positive or negative. Or we can use one of these ones where we don't have to determine if it's going to be positive or negative. Which one would be easier? The one where we don't have to, right? The one where we don't have to. Okay? So we can either use the 1 minus cosine over sine or sine over 1 plus cosine. Ultimately, does that matter? No. So either one of these will be useful for us. So we're going to say that this is equal to 1 minus the cosine of that angle divided by the sine of that angle. Now, what is the angle that we're concerned with, though, for the cosine and sine? The 30. The 30. Okay, so the 30 gets plugged into here and here. Okay. So what is the cosine of a 30-degree angle? Radical 3 over 2. What is the sine of a 30-degree angle? 1/2. Got a complex fraction here. I'd like to have one single fraction up on the top. Well, 1 is very easy because 1 can be anything over itself. We want it to be 2 over 2. Okay. So now I can add those up on top, or I'm sorry, subtract those, and what would we get up top? 2 minus radical 3 over 2. We're not going to divide by a half. We're going to do what? We're going to multiply it by the reciprocal, which will give us what? 2 minus radical 3. All right. Let's see if that seems reasonable. Where's 195 degrees? Quadrant 3, right? Tangent in quadrant 3 has to be positive, right? All students take. Tangent's positive in quadrant 3. Is 2 minus radical 3 positive? And I do not want you going to your calculator. Is 2 minus radical 3 a positive number or a negative number? It's got to be a positive number, right? Square root of 3. Well, it's less than the square root of 4, right? And what's the square root of 4? 2. And 2 minus 2 would be 0. Well, if radical 3 is less than the square root of 4, we're going to have 2 minus something that is less than 2. Is that going to be positive? Absolutely. Even easier, can I just type in the tangent of 195 degrees and verify that it's 2 minus radical 3? Yeah, the calculator's not going to give you 2 minus radical 3, but it will give you the decimal approximation for it. Okay? So it really was a good example because it was more involved than just a half angle identity. If they wanted us to use a half angle identity, then we didn't just say that 195 is half of what? Well, it's half of 390. Well, 390 is outside of the circle that we want, so then we used a coterminal angle and said, well, 390 is the exact same as 30. Okay? So the tangent of 195 behaves the exact same way as the tangent of half of 30. Now we use our identities, and we can work our way through there. And again, could we use any one of those three identities? Why did I stay away from the plus minus radical one? Number one, I didn't want to have to figure out if it was a positive or negative. And number two, it's got a radical. I'd rather not work with the radical if I didn't have to. Okay? Now, how are we going to figure that out otherwise? Let me give you a sign example. I want you to find, let's use the sine of 120 degrees using a half angle identity. I want you to find the exact value of the sine of 120 degrees using a half angle identity. Well, we're going to say then that 120 is half of 240. Is half of 240. Well, our identity for sine says that it's going to be positive or negative radical 1 plus or minus cosine over 2. 1 minus cosine. 1 minus cosine what? 240. Yeah, well, whatever we're taking half of is what comes over into here. Half of 240. So positive or negative, square root of, okay, cosine of 240. Now we've got to come kind of out of a sidebar here and figure out what the cosine of 240 is. Okay, well, where is 240? It's third quadrant, right? 240 is quadrant 3, where cosine is negative. So negative cosine. And what would be a reference angle for that 240? Where are we? Quadrant 3, and how do we find reference in 3? Minus 180. 240 minus 180 is 60 degrees. And what is the cosine of a 60-degree angle? One half. Negative 1/2. Okay. So now I can come up here and say, okay, I've got 1 minus Cosine of 240 was negative 1/2. Well, minus a negative is going to give us plus 1/2 divided by 2. I can change 1 to anything over the same thing. Really, again, we want it to be what over what? Okay, so 2 plus 1 is 3 over 2. And 3 over 2 divided by 2. Dividing by 2 is multiplying by 1/2. So 3 over 2 times 1 over 2 is 3/4. Positive, negative, radical 3/4. Okay. Which is positive or negative radical 3 over 2. The 4 comes out as a 2. Okay, now we've got to figure out what are we going to do with the positive or the negative. And in this case, it's really quite simple. We know that 120 degrees is where? Second quadrant, where sine is positive. So in quadrant 2, sine is positive. We want the positive value. Okay. But what if we didn't know that right off the bat? Okay. Well, we've got to figure out what quadrant the angle is in. Okay. This one was in, what, 240 was in 3. So 3 is defined to be where to where? 180 to 270. Well, what's half of that? What's half of 180? 90. What's half of 270? 135. 90 to 135 puts me in quadrant 2. So if I was dealing with a third quadrant angle, half of that puts me into quadrant 2, where only sine is positive. Okay, so that's what you got to determine. You got to figure out what quadrant the angle you're taking half of is in, and then you take half of that quadrant. Half of quadrant 1 is still going to put you in 1. Half of quadrant 2, 90, half of 90 is 45. Half of 180 is 90. So if the angle you're dealing with is in quadrant 1 or 2, half of that angle is going to put you into 1. If you're in 3 or 4, half of 3 or 4 is going to take you up into 2. Okay? So you've got to say, okay, this is the angle I'm starting with. It's in 1 or 2. Half of that puts me in 1. Everything is going to be positive. The angle I'm dealing with is in quadrant 3 or 4. Half of that puts me up into 2, where only sine is positive, where only our sine is positive. Okay, so using half angle identities. Okay, I think there's one more example that we want to go through in the notes, and then I'm going to go to your questions. Have we done this one yet? I don't believe we have. No? Okay. So this one here is using a power reducer. So again, let me quickly refresh you here on the power reducers. The power reducers say that sine squared is 1 minus cosine 2u divided by 2. Cosine squared is 1 plus cosine 2u over 2. And then tangent squared is the sine divided by the cosine. The 2's knock out, so 1 minus over 1 plus cosine 2u's. Okay. Very, very similar to the half angle identities here. Okay. Well, this example wants me to rewrite sine to the 4th. Sine to the 4th. Well, first and foremost, sine to the 4th is sine to the what times sine to the what? Squared times sine squared. So sine squared x squared. That's sine to the 4th. But from my power reducers, I know that sine squared is equal to what? 1 minus cosine 2u divided by 2. And then another one. 1 minus cosine 2u divided by 2. Sine to the 4th is sine squared times sine squared. Well, with our power reducers, sine squared is 1 minus cosine 2u over 2. What's being indicated for me to do now, though? Multiplication, right? And how do we multiply fractions? Straight across. So the denominator, 2 over 2, is going to be 4. Or 2 times 2 is 4. But up on top, what do we have to do? We've got to do a FOIL. Now, is it a simple FOIL? No, because they're not conjugates, right? They're not conjugates. So I've got to do the full thing. So 1 times 1 is 1. And then we get a negative cosine 2u. But how many negative cosine 2u's? 2. Minus 2 cosine 2u's. And then a negative times a negative is a positive cosine squared 2u, right? Now, but it said functions with no power greater than 1. Do I still have a power greater than 1? Yeah, I do. But I can use the cosine power reducer, right? What does it say that cosine squared u is equal to? 1 plus cosine 2u, right? 1 plus cosine 2u over 2. Well, we don't have cosine squared u. We have cosine squared 2u. So we just need to replace this with, every u is going to get replaced with 2u. So 2 times 2u is going to be a 4u. So I can just simply 1 minus 2 cosine 2u plus, okay, here we go, 1 plus cosine 2u divided by 2. All still over what? Well, dividing by 4 is multiplying by what? A fourth, right? One fourth. Two times a fourth is what? 2/4, which is a half. Okay, so cosine 2u over 2. And then a 1/4 and a half is an 1/8. An 1/8. Have I done what they've asked me to do? Yeah, I mean, at this point right here, we've done what they've asked us to do. Can I still simplify? Can I get one term out of this? Yeah, what would my common denominator be? 8. So this would be 4 cosine 2u's over 8. And this would become 2/8. What is our denominator now for everything? 8. What is 2 plus 1? 3 minus 4 cosine 2u plus cosine 4u. We were done right here, folks. We were done. We no longer have a power greater than 1. But we can simplify that down into one term to using our power reducers. We can always use power reducers to get rid of squares. Now, folks, would we really ever do that? Probably not. Once we have sine squareds, we can have a 1 minus cosine squared if we want. Okay. But power reducers will allow us to get rid of powers. Okay. What if we had a cosine cubed, or I'm sorry, a sine cubed up here? What if it was sine cubed x instead of sine to the 4th? Well, sine cubed is still sine squared times sine. And then I could have used my power reducer here. 1 minus cosine 2u over 2 times sine x. Are all my powers gone now? Yes, absolutely. So it doesn't have to be an even power. You just need it to have a square breakout. All right with that one? Very good. Those are half angles. Did we do this one already? Okay, let's go ahead and finish it up then. And I remember why we didn't finish it now, because after we make our identity change here for the double angle, it becomes just a basic one that we'd solved before. But what is the issue that I'm having right here with this equation? Why can we not solve it the way it is? I mean, we've got the same trig functions. That's always a plus for us, right? We want to try to have the same trig functions. We've got different angles, right? I have the sine of 2x along with the sine of x. We can't solve equations like this. If we're going to solve a trig equation, all of the trig functions have to be with the same angle. Well, is there anything I can do with sine x? No, but is there something I can do with sine 2x? Yes, that is a double angle identity. Double angle identity. Now, is this the double angle identity that has multiple ones, or is there only one thing for sine 2x? There's only one thing for sine 2x. And what is that substitution for sine 2x? 2 sine x cosine x. And what are we going to do with that sine x over on the other side? Yeah, we're going to bring it over. A minus sine x equals 0. Now can we solve this equation? Yes, because all of the angles are, they're all the same. They're all x now, right? Okay. We would still like to have what, though? All the same trig functions. But is that a necessity? No, the angles were a necessity. Different trig functions, that's all right. Because most of the times, what are we going to be able to do with those different trig functions? Well, there's nothing we can change here, though. There's no power reducers or anything like that. We just got sine x and cosine x. There's nothing else I can do with sine x and cosine x. But what? I can factor them away from each other, can't I? What do those two terms up there share in common? The sine x. And if I factor that sine x away, will I now have separated the sines and cosines? Absolutely I will have. I factor out the sine x, leaves me with 2 cosine x minus 1 equal to 0. Okay. So what is sine x equal to? Sine x equals 0, and what is cosine x equal to? Positive 1 divided by 2. 0 for sine. I always think back to my graphs for sine. Where is sine equal to 0? 0, pi, and 2 pi. But are we including the 2 pi? No. So x equals 0 and pi. Cosine has to equal 1/2. Well, first and foremost, where is cosine positive? First and fourth, right? First and fourth quadrant. And what is our reference angle? When is cosine 1/2? 60 degrees. Pi over 3. Okay, so that is our first quadrant angle, x equals pi over 3. But how do I put a reference angle into quadrant 4? Subtract from 2 pi, 360. Yep, subtracting off of 2 pi. Well, 2 pi, 2 wholes, is how many thirds? 6 thirds. What's 6 minus 1? 5. Pi over 3. So how many solutions does this equation have? 4 solutions in that range. X equaled 0, pi over 3, pi, and 5 pi over 3. But what did I neglect to do before I kind of finalized my answer? We should always be checking these, shouldn't we? Always be checking these. But where do we check? Calculator, we're going to be in what mode when we check? Radian. We're going to store x as 0, and then type in what? The very original. 1 means yes, 0 means no. And then we'll check all 4 of those. All 4 of those will work in this one here, though. We never had to divide out by anything or multiply by anything that would have given me an extraneous root. Okay. So I think, I do recall now, I think we got to that point right there where we had the sine and the cosine defined. We just needed to finish it up on that one. Okay? Questions on that, folks? Again, folks, if you do not yet have a reference sheet for all of these, you really need to get one. You really should have a separate sheet of paper that has all, what we said, 9 yesterday, 9 sets of identities listed out right there for you, so you've got quick reference and a good study guide off of those. We're going to take homework questions for the rest of the period, but before I do that, I'm going to give you a graded homework assignment. Now, this is only on the last 2 sections, 5.3 and 5.4. 5.3 was the sum and difference, and then 5.4 was the multiple ones. So this is only on 5.3 and 5.4, so take one and send them around. It's got multiple choice on it, but we've seen these before, right? What do I need to see? Yeah, you're going to show me all of your work, and then you're just going to correspond it back to one of the multiple choice answers on that, okay? So we've done examples of a couple of these already. I want you to find the cosine of a 75, the tangent of 7 pi over 2. How did we get 75 degrees? Adding or subtracting. So these are your sum and difference identities. 1 and 2 are sum and difference ones. Number 3, find the exact value by using a half angle identity. Okay. Find all solutions to the equation in 0 to 2 pi. So solving equations on 4, 5, and 6. Same thing in 7, 8, and 9, but we've got some half angle stuff up there in power reducers. And then 9 through 13 are identities. Okay, prove that one side looks like the other side. Okay, so again here, folks, you will not be handing me this worksheet back. You won't be doing any worksheet or work on the worksheet. This is all going to be a separate sheet. You're going to show out the work, so you're going to do all the work for the cosine of a 75. You're going to find it looked like this one. So then you say, okay, it's number or letter C. But I need to see all work. There's none of these that you'll get credit for just putting a multiple choice selection down on. Yeah, like a normal homework, you want to do it on Notability, that's absolutely fine. Like you normally do, absolutely. Absolutely. Okay. And again, if not, you're going to be taking a picture of it and send it that way. But yeah, Notability is perfect. Okay. This is not going to be due, let's go Tuesday on this. We're going to go Tuesday on this, so you'll have the weekend and Monday. Okay, so we're going to go Tuesday that this is due, folks, Tuesday. All right, back into your regular homeworks then. What do we have question on? Austin, go ahead. 54, and this is 5.3 or 5.4? 5.4? Can you give me a page number, please? 476. And you said 54? Good. A good one. A connection up to geometry. Good. And this is really what pre-calculus is all about, is making the connections between, you know, you had individually Algebra 1, then you had individually geometry, and then individually trig. And pre-calc tries to make the connections between all of the courses and show how they are interrelated and not just separate entities. But what we've got here is a rhombus. Please tell me what a rhombus is. It is an equilateral quadrilateral. It's an equilateral quadrilateral. What qualifies as being a rhombus as well? It depends. A kite could or could not be. Diamonds, same as well. They could or could not be a rhombus. But what is definitely a rhombus? A square. A square is definitely a rhombus, right? Okay, because it's an equilateral quadrilateral. So a rhombus is equilateral. It just might not have all 4 angles being right angles. Okay, it's a square that got tipped over. Okay, a rhombus is a quadrilateral with equal sides. The diagonals of a rhombus bisect the angles of the rhombus. Now the rhombus is the one where the diagonals did everything. The diagonals bisected each other, so this length and this length were the same. This length and this length were the same. Were all 4 of them the same, though? No. There's one diagonal that's longer than the other. But the midpoints, this one and this one are the same. This one and this one are the same. They are also what to each other? Perpendicular to each other. What do they do to the base angles? They bisect all the base angles. Okay, so here with the rhombus, the diagonals did everything. They bisected each other. They bisected the base angles. They were perpendicular to each other. So each one of these individual triangles in here is what kind of a triangle? A right triangle. They're all right triangles. Okay. Let angle ABC be theta. So that's this whole angle right here. That's theta. But what does the diagonal do to the base angle? So this up here is theta divided by 2, and this down here is theta divided by 2. This up here is theta divided by 2, and that's theta divided by 2, because opposite angles of a quadrilateral, opposite angles of a rhombus are congruent to each other. Let D1 be the length of AC. So if D1 is the length of AC, then from A to here is how much of D1? 1/2 of D1. So that's D1 divided by 2. This is D1 divided by 2 as well. And D2 be the length, so this is D2 divided by 2 and D2 divided by 2. Okay, now it's kind of cramped, but in just a second here we're going to kind of just take a section of it and blow it up. So that the cosine of theta divided by 2 is equal to D2 over 2x, and the sine of theta divided by 2 is that. Okay, so sine, cosine. Basic triangles, right? Let's look at, I'm going to call this one in here E. Let's look at BEA. BA, and then our midpoint E here. So we've said already that this is half of diagonal 1. This down here is half of diagonal 2, right? BD was diagonal 2. Yep, so that was half of it. We already know that this angle right here is half of theta. So this side is opposite of angle 1/2 theta. This side is adjacent to angle 1/2 theta. And this up here is our hypotenuse, right? It's our hypotenuse. Do we know the length of our hypotenuse? We don't, do we? But could we determine it? Yeah, I know these two sides, right? So how would we find our hypotenuse? Well, our hypotenuse squared would have to be equal to diagonal 1 divided by 2 squared plus diagonal 2 divided by 2 squared. So diagonal 1 squared over 4, diagonal 2 squared divided by 4. So diagonal 1 squared plus diagonal 2 squared over 4 is my hypotenuse squared. So what would we do to get our hypotenuse? We'd take the square root of that, which is nice because 4 is going to come out as what? 2. So my hypotenuse is the square root of diagonal 1 squared plus diagonal 2 squared divided by 2. Do I now know all 3 sides? Yeah, I know all 3 sides. Where's their x coming from, though? Did I overlook something? Oh, duh. I'm sorry. We just did a lot of extra work that we didn't need to. What do they have x defined as? Looking at your diagram, what do they have x defined as? The side of each of the rhombuses, right? Which happens to be the what of every one of those individual right triangles? The hypotenuse. My hypotenuse is what? X. My hypotenuse is x. Okay. So, part A. The cosine of any angle is equal to the ratio of which 2 sides? A over H. A over H. Well, instead of dividing by x, we're going to multiply by what? 1 over x. And we get diagonal 2 divided by 2x. Is that what we wanted?
May I have your attention, please?
Same thing? Yes, same thing.
Who plan on attending the senior tea on Friday, May 15th from 3 to 4 at the miners cabin may have an 11 o'clock dismissal that Friday if they return assigned permission slips from Mr. Butler by next Monday, May 11th. Anyone who leaves early must attend the senior tea. Any questions, please see Ms. Pulaski or Mr. Butler. Any senior planning on attending the junior-senior banquet on Friday night, May 15th, in the elementary cafeteria from 6 to 9 p.m. should sign up outside Mr. Butler's room. Swimming, basketball, kickball, and other games are available. Hot dogs, hamburgers, and other picnic food will be served. Seniors who work the Maple Fest go for free. All others going, there will be a $10 charge. Attention juniors. Sign-up sheet for the junior-senior banquet is located in the main office. You have until next Monday to sign up. Only those signed up and paid will be available to go. Also, any junior that would like to sell beef jerky sticks for the class should go to the elementary school any day after school to see Mrs. Varno. Prom committee will be meeting next Monday at the Woods at Bear Creek at 3 o'clock. See Ms. Pulaski with any questions. Following students, please report to the office. Alicia Defoe, Kurt Miller, Kevin Harrington. Thanks for your attention.
So now in part B, they wanted me to find the sign of theta. Well, theta is 2 times of half of theta. What's half of theta times 2? Theta. So we're going to use a double angle identity for sine. And what does the double angle identity of sine tell me? What's the sine of 2 theta? 2 sine theta, cosine theta. But our theta is really half of theta. So 2 sine of half theta, cosine of half theta. We found these two in part A. We substitute and evaluate it out. A great connection between geometry and trig there. Okay? So folks, looking through my emails here, I don't have a lot of 5-3s. 5-4s, we've now finished 5-4, so we should have 5-4s for tomorrow. And then we've got that graded homework, which we're going till Tuesday on. Till Tuesday. Okay, so there's multiple homeworks that are due right now. Okay? Have a good weekend. I'm sorry, have a good evening, folks.